This is the 5-3 review, number 10, the free response problem, and in this problem calculators are allowed. So the first thing we see is that we have a graph of a function f, and g is the accumulation of f from 0 to x squared. So for part A, we have three different things that we want to compute. The first one is g of 2, which means I'm going to plug 2 into this, which will give me 0 to 4 of f of t dt. That means I need to accumulate on this graph from 0 until 4. So if we look at this accumulation, we can see that this triangle above will be canceled out by this triangle underneath, so I'll be left with just this negative area, or not negative area, but this negative accumulation here of -6. The next thing we want is g prime of 2. So g prime of 2 requires that I take the derivative of this and then plug in 2. So let's do g prime of x first, and then we'll plug in the 2. If I take the derivative of this, the first thing I hit is the integral. So that's Fundamental Theorem of Calculus Part 1. I plug that x squared in, and then I have to do the chain rule because that was not just a regular x, it was an x squared. So I will multiply by what got plugged in. So now if I look at this and I try to compute g prime of 2, that's going to be f of 2 squared, or 4, times a 2 times a 2. If I multiply that out, I'll have a 4 times an f of 4. So I come onto my function f and I look at 4 and see that its y-coordinate is -3. So I end up with an output on the slope that is -12. The last thing that I need to do for part A is g double prime of 2. So again, let's take the derivative first with the x's and then plug in the 2. If I look at g prime, I have two things that are being multiplied. So that's going to require that I do the product rule. I'll have the first one times the derivative of the second plus the second times the derivative of the first. So the derivative of the first will be f prime of the inside unchanged times the derivative of the inside. So that ends up being 2 of those f of x squareds plus 4x squared times the slope of f evaluated at x squared. So now we're ready to look to see what g double prime of 2 will be. That's going to be 2 of those f of 4s plus 4 times 2 squared is 16 times the slope of f at 4. So if I go look at the picture, I can see that f of 4 is the y-coordinate at 4. That's a -3. And I can see that the slope at 4 on f is going to be 0. So I end up with a second derivative value that is -6. That is worth 1, 2, 3 points apiece, or total, so 3 points in all. If we look at part B now, it says, does g have a relative min, a relative max, or neither at x equals 1? Well, in order to have an extreme value at 1, we need g prime of 1 to be 0 or undefined, and we need g prime of 1 to change sign. So if we look at g prime, remember from up above that it was f of x squared times 2x, so g prime of 1 will be f of 1 times 2. So we'll go look at the picture and see what the y-coordinate of f at 1 is, and we can see that it is 0. So down here I have a 0 times 2, which is 0, so it's definitely a candidate. So to determine whether or not we have a max or min or neither, we need to examine the sign of g prime. So g prime, if you recall, was this f of x squared times a 2x. So let's do a sign chart for g prime and look to the left and right of 1. We know at 1 that we had a 0. If I go a little bit to the left, say at 0, I can plug 0 into the derivative function, and I'll be doing it here but putting it on the sign chart down below. I can plug in 0 for g prime, and I'll get f of 0, which is a positive number, times 0, so that doesn't really help me. So let's try right here, say a half. If I plug in a half, that'll be f of 1/4, which is going to be above the x-axis, so that's positive, and 2 times a half is also a positive number. So I got a positive output when I plugged in a half. So this will be positive. Now let's go a little bit bigger than 1. Let's try 2. If I plug 2 in, then that means I will be plugging f of 4, and f of 4 was a negative number times 2 times 2 will give me positive, so a negative times a positive will end up giving me a negative value. Because g prime changed from positive to negative, we can see that the original function had a maximum at 1. So we can write g has a max at x equals 1, because you can either say g is continuous or g prime of 1 equals 0, and g prime of x changes from positive to negative at x equals 1. That was worth 2 points. 1 point for the answer, yes, you've got a relative max, and 1 point for the reason.